Moss spores survive prolonged space exposure, hinting at future role in extraterrestrial ecosystems. Recent research reveals that spores from the spreading earth moss, Fiscomitrella patens, demonstrate remarkable resilience, surviving up to 9 months exposed to the harsh conditions outside the International Space Station, ISS, and retaining the ability to reproduce upon return to Earth. This finding, published in iScience, suggests mosses could be instrumental in developing sustainable life support systems and even establishing rudimentary ecosystems on other planets. Moss, as a pioneer species, Fiscomitrella patens, is already known for colonizing barren environments on Earth, making it a natural candidate for extraterrestrial applications. The study, led by Dr. Tomomichi Fujita of Hokkaido University, confirms that its spores can withstand extreme stress. Vacuum conditions, deep freezing, high temperatures, and intense radiation. Researchers exposed moss structures to simulated space environments on Earth, discovering that spores encased in a protective structure called a sporangium were the most durable. These spores germinated even after exposure to UVC radiation levels exceeding 100,000 joules per square meter. 9 months on the ISS to validate these findings, the team sent sporangium-encased spores to the ISS aboard the Cygnus NG-17 spacecraft, attaching them to the station's exterior for 9 months. The results were striking. Nearly 86% of the space-exposed spores germinated upon return to Earth, only slightly lower than the 97% germination rate of control spores kept on Earth. While some degradation of chlorophyll was observed, the overall viability remained high. If such spores can endure long-term exposure during interplanetary travel and then successfully revive upon rehydration and warming, they could one day contribute to establishing basic ecosystems beyond Earth, Dr. Fujita stated. Implications for space exploration: the study's implications extend beyond mere survival. Mosses could potentially contribute to oxygen generation, humidity control, or even soil formation on other planets, reducing reliance on Earth-based resources for long-duration missions. However, Fujita acknowledges that further research is needed to determine whether moss can germinate and grow under the full spectrum of extraterrestrial conditions: gravity, atmosphere, radiation. Expert commentary Dr. Agata Zupanska of the SETI Institute, while praising the study, notes that resilience in spores is a known phenomenon. She also emphasizes that the ISS exterior doesn't fully replicate the challenges of deep space or planetary surfaces. The true test lies in enabling moss to thrive, not just survive, in these environments. The survival of moss spores in space is a crucial first step toward long-term, self-sustaining life support systems. But much work remains before we see Martian gardens sprouting from extraterrestrial soil.